All right, guys, we're going to move on to 7.2, which is product and quotient exponent properties. And this is just going to add a few more tools into our toolbox as far as exponent properties go. A lot of these I think you've probably already seen before. Matter of fact, I know you've seen them before. Maybe you don't remember. But we'll take a look at this, work through a few examples, and then I'm going to turn you loose for some practice. So first, let's talk about product and quotient, the words product and quotient. A product, if you will remember, is an answer to a multiplication problem. So that in and of itself helps us understand that we're going to be multiplying exponents. And then it talks about the quotient exponent properties. Those obviously a quotient is an answer to a division problem. So we're going to be talking about dividing exponents as well. So let's just dive right in, work with a couple of examples here. So let's go with this one first. X to the third times x squared. Okay, and here's what you need to remember about when you're multiplying exponents. When you're multiplying exponents, you actually add them. Okay, so instead of this, we would initially think, well, I just multiply 3 times 2. And we might think that that's x to the 6, but I want to tell you that that is incorrect. Okay, that is not correct. When you multiply exponents, you actually need to add them, okay? So this would actually be x to the 5th. And I think it maybe makes more sense when we do quotient, but we'll look at that in just a second. So again, if I had y to the 5th, for example, times y to the 3rd, it is not y to the 15th, which would be 5 times 3. When I multiply exponents, I actually add them. So I would just have 5 plus 3, which would make 8. So y to the 8th would be the answer for this particular one. So all you need to remember, when you multiply exponents, you actually use addition. And that makes sense because multiplication is just a repeated form of addition, okay? So now let's take a look here, and let's go ahead and try some division. So for division, let's say that we have x to the 6th. That was awful. I'm going to try that again. All right, if we had x to the 6th, and we were dividing that by x to the 3rd. Let's think about what we're really saying when we say x to the 6th. Remember that this exponent simply says how many times you're going to repeat this base, okay? So x really here is my base. So I'm going to rewrite this just to kind of help you to understand how this works. So I've got x to the 6th. That's really the same thing as x times x times x times x times x times x. There's 6 x's there, okay? On the bottom, what I really have is I have x to the 3rd, which is the same thing as x times x times x. So again, you can kind of get the idea here of what's really happened. And this is kind of a visual representation of what this really is, what this problem really is. Well, think about what happens when you have the same number on top and bottom. For example, if I had 6 divided by 6, well, what happens there? 6 divided by 6 just equals 1, and really 1 is just like having something canceled, right? If I take 4 times 1, I'm still going to end up with 4. It doesn't really change my problem at all. So really what happens when you've got the same thing in your numerator and denominator is those things actually cancel. So let's look at what happens here with this particular problem. I have 1x here, so I'm going to cancel that out with this x on the bottom. I have another x here, and I have another x there, so those cancel out. Again, anytime I have one on top and one on bottom, I can cancel those. So this is going to cancel, and this is going to cancel. Now my question to you is, how many x's do I have left, and where are they at? Are they on top or are they on bottom? Well, if you notice, I have 3 x's here on top. So I have x times x times x, which is the same thing as x to the 3rd, right, over 1, which very simply just simplifies to x to the 3rd. So this particular problem right here would just end up being x to the 3rd. All right, so let's use that same concept and think about what we're doing here. Let's take another one, y to the 4th over y to the 6th. Okay, so I've got y to the 4th over y to the 6th. Now let's think about what we have here. Let's go ahead and do the same thing we did up top. We'll do 4 y's on top, and on the bottom we'll do 6 y's. All right. So now whatever I have on top, I can also cancel out with something on bottom. So notice those cancel, those cancel, those cancel, and those cancel. So the only thing I have left is I have two y's, y times y on the bottom, okay? But on the top, I really have nothing. It's kind of canceled out, okay? So what I actually end up with an answer on this one is 1 over y squared. So here's what you need to remember about division. When you divide exponents, you actually subtract, okay? So I'm going to take 6 minus 3. That leaves me with x to the third. Really, in essence, I took 6 minus 4, and it left me with 2, but those 2 remained on the bottom, not on the top, okay? So when I multiply exponents, I actually add them. When I divide exponents, I actually subtract them. So let's work through another couple examples of each, and these will get progressively harder. So that way we'll be ready for our practice. So let's look at another example here. What if we have, for example, 2y to the fourth times 3y, just 3y. Okay, so what do I need to do? Well, what you need to think about is that really you have multiplication between all of these things. So really I have 2 times y to the fourth times 3 times y, if I think about it that way. So what you can do in this instance is you can actually just kind of worry about your coefficients first, which are your numbers that are in front of the variables, and go ahead and multiply those first, because remember, multiplication is commutative. So I could move these things around. In other words, I could take 2 times 3 and then do times y to the fourth times y. It is perfectly legal to do that because, again, the commutative property says that I can move things around. So basically what I'm going to do is I'm just going to take 2 times 3 first. So 2 times 3 would be 6. And then the only thing I have left, if you think about it, I'm just going to kind of mark it out here because I did that. The only thing I have left now is y to the fourth times y. Well, y to the fourth times y, let me ask you, what exponent is right here even though I don't see it? Well, I really have 1y, right? 1 is all I have. So if I multiply exponents, I actually add them. So y to the fourth times y to the first would be y to the fifth, okay? So this would be our answer for this particular problem. So let's move on to another one that maybe has got additional variables with it, and maybe this will help rejuvenate and get some more ideas going, all right? So let's look at this one. We've got 4m to the third n times negative 3m n squared, okay? So now you notice I've got some things in parentheses. That doesn't really matter. That still means that I've just got multiplication in between here. I could put the raised dot in between there. It wouldn't change the problem at all. But again, I'm just going to understand here that I've got multiplication between all of these things, okay? So I'm going to use the same strategy. I'm going to go ahead and just multiply my coefficients first. So 4 times negative 3 would be negative 12, okay? Then I'm going to take each variable on its own and think about it. So my next part that I need to work on, I'm done with that, is my m's. You notice I have m to the third times m. And again, there's an exponent of 1 here, even though I can't see it. So m to the third times m to the first is going to be m to the fourth. Remember, when I multiply exponents, I actually add them, okay? Last but certainly not least, I have n, and again, that would be n to the first. And if that helps you to put that 1 in there, go ahead and do it. It's fine. N to the first times n to the second means that I'm going to end up with n to the third. So that would be my final answer for this particular problem here. Again, these are not really complicated. You have to take each part at a time. All right, so let's look at 2 more problems. These are division problems. And let's see if this is going to help us as well. Here we go. We've got 24x to the fifth over 4x squared. All right, so again, we're going to use a similar strategy in that we could also split this out, and you don't have to do this every time. I'm just trying to do it to help explain maybe what's going on. But really, I could rewrite this as 24 times x to the fifth. As a matter of fact, I could split these out as two different fractions. That would be perfectly legal for me to do that. And the reason being is I could put this back together and it doesn't change the problem at all. So I could literally put the 4 here and put the x squared over here. You notice I've kind of grouped things, but if I were to multiply this back out, I'm going to end up with this same answer again, okay? But this helps me to try to figure out what I need to do. I've kind of grouped my coefficients together and I've grouped my variables together. So notice what happens here. What is 24 divided by 4? It's just a division problem, right? A fraction is nothing more than a division problem. So 24 divided by 4 would give me 6. And then I have x to the fifth over x squared. So when I'm dividing exponents, I actually subtract. And you remember I have more x's on top than I have on bottom. So that means this is going to be 6x to the third, okay? That would be my final answer. Again, that may have looked really daunting when we first looked at it, but it's not really that complex at all. All right, so let's look at one more. This one will be our last one, and it will be just a little more in-depth than maybe what we've looked at in previous examples. So here we go. You ready? 4y to the fourth, z to the third, over or divided by 12 y to the negative 1. You knew we had to bring those in there somewhere, right? Z to the fifth. Now let's think about what we really have here, and we're going to really think about what we have on top and what we have on bottom, okay? So again, we could split this out into different parts if you wanted to do that. 4 over 12 times y to the fourth over y to the negative 1 times z to the third over z to the fifth. Okay, so now let's take each part and let's try to see if we can figure out what's going on. You notice here I've got 4 divided by 12. Now this is a little bit different than what we had a few minutes ago. You remember a few minutes ago we had our larger number up top and we had the 4 down at the bottom. Well, this time we don't. We have 4 divided by 12. So what I want you to understand is that this is actually a fraction, and we can simplify this fraction. So 4/12, 4 will go into 4 one time, and 4 will go into 12 three times. So now all of a sudden our 3 is at the bottom, not at the top, okay? So I wanted you to see that. Now we're going to multiply that times, and let's start working on our next part. So I have y to the fourth, and I have y to the negative 1 here. Now let's think about what happens when we have a negative exponent. You remember when we have a negative exponent that we actually need to move that to the other. If it's the denominator, we need to move it to the numerator. If it's the numerator, we need to move it to the denominator. So I'm going to actually move this up to the top, which is going to leave nothing down here at the bottom. So I'm going to end up with y to the fifth. And again, I could go ahead and write that over 1. It doesn't make any difference. And now I'm left with this last part, which is z to the third over z to the fifth. Now remember, I've got 3 z's on top and I've got 5 z's on the bottom, okay? So that means I'm going to have more z's on the bottom than I'm going to have on the top. I'm not going to have matches for all of them. So what's going to happen here is I'm going to have 2 z's left over at the bottom, and I'm going to have nothing left over at the top, okay? So now let's do the last step. Let's just multiply this straight through. So 1 times y to the fifth would just still be y to the fifth. Y to the fifth times 1, it just remains the same, okay? So all I'm going to end up left with on top is y to the fifth. Now let's go across the bottom. 3 times 1 is 3. 3 times z squared is just going to simply be 3z squared, okay? So this would be our final answer for this particular problem, okay? So your practice is, I've actually looked at your practice and kind of made some problems based on that, but your practice is going to look very, very similar to this. So this is actually what you have right here. And again, you can see some of these same type problems that you have here. I think there's about 16 problems here, which sounds like a lot, but honestly, it didn't take us very long just to go through those 5 or 6 that we did just a few minutes ago. So you're going to do very well, I believe, on this assignment. Again, this is something maybe you've already seen before, but I just wanted to touch base with you and give you a few examples that you can go back and look at. So if you need any help, obviously, just get back with us and let us know, and we'd be glad to help.